Namaste everyone, welcome again to the class. Now let us see the next problem. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. Means when the person is diseased person, then laboratory test results positive. This is 99% effective, means 0.99 is the possibility of detecting positive result when the person is diseased. However, the test also yield a false positive result for 0.5% of the healthy person. But if a healthy person goes for a test, then this laboratory test results 0.5% positive, means even if he does not have disease, the results shows that he has a disease. The chances are 0.5%. If the healthy person is tested, then with probability of 0.5% means 0.005 is the probability that test will imply that he has a disease. Now if 0.1% of the population actually has disease, what is the probability that a person has a disease when given that the test result is positive? So again you can understand that we have a sample space with two partitions. One is a diseased person and other is a healthy person, and we have test result which is positive. So here I will define E1 event as, even we will consider event that the person is diseased person. So I will say even is the person is having disease. And I will consider E2 that the person is not having disease or the person is healthy. And I will consider A as the event that test result is positive. Now possibility of person having disease is 0.1%, okay, is 0.1%. Now 0.1% means 0.1 divided by 100, this is 1 divided by 1000. This is possibility of E1. Then what is possibility of E2? If 0.1% are diseased person, then 0.9% will be healthy. That means 0.9 divided by 100, that is 9 divided by 1000. So 9 divided by 1000 is the possibility of getting a healthy person. Something wrong I think I am doing, not 0.9%, it is 99.9%. Yes. So let us erase this thing. When diseased person is 0.1%, then healthy person will be 99.9%. So 99.9 is 99.9 divided by 100, which is equals to 999 divided by 1000. Now possibility of A that the test result is positive when we know that the person is diseased is 99%, right? It is given 99%. Okay, so this is 99 divided by 100, and possibility of A by E2 means when it is a healthy person, then also the test is resulting positive with 0.5% possibility. 0.5% means 0.5 divided by 100, that is 5 divided by 1000. Now we have to find possibility of E1 by A. Okay, we have it is given that the test result is positive. We have to find the possibility that the person selected is a diseased person. What is the probability that the person has a disease given that his test result is positive? So E upon A1 we have to find out. We use Bayes theorem. So I will say that by using Bayes theorem, we have possibility of E1 by A is equals to possibility of E1 multiplied by possibility of A by E1 whole divided by possibility of E1 into possibility of A by E1 plus possibility of E2 into possibility of A by E2. Now let us put the values. Possibility of E1 is 1 upon 1000 multiplied by A by E1 is 5 divided by 1000. Whole divided by, here we have 1 divided by 1000 multiplied divided by 5 divided by 1000 plus probability of E2 is 999. So it is 999 divided by 1000 multiplied by possibility of A divided by E2 is 5 divided by 1000. A by E1 is 99 divided by 100 means 990 divided by 1000. Everything is in 1000, so better express this also as something divided by 1000. So 990, here it is 990 divided by 1000. And here it is 999 divided by 1000 into, this is 5 divided by 1000. So this will become 990 divided by 1000 and denominator will become 5 plus, now 999 into 5. So 5 9s are 45, 4, 5 9s are 45, 45 plus 4, 49, 4, 5 9s are 45 plus 4, 49 and whole divided by 1000. So this is equal to 990. Now this denominator 1000 will cancel, divided by, when we add this 5 we get 4995 will become 5000. So this is 5000. Now this 0 and this 0 we will cancel and this is 99 divided by 500. So 99 divided by 500 will be the chances that the person, okay, who has detected positive will be a diseased person, right? Let us check calculation again. E1 person having disease, so it is 0.1. 0.1 means 1 upon 1000. E2, the person does not have disease, 99.9, that is 999 divided by 1000. Probability that a diseased person is getting positive result is 99 divided by 100, that is 990 divided by 1000, that is also okay. And A divided by A2, the person is resulting, okay, positive test when he is not having disease. So A divided by A2 is 5 divided by 1000. So everything is perfect. A by E1. Acha, A by E1. See, here we have done mistake. A by E1 is what? A by E1 is 990 divided by 1000. So here in place of 5 we should write 990. So here in place of 5 we will add 990. So when we add 990, what we will get? We will get numerator as 990 and our denominator will be 5. Then 9 plus 9 18, 1 carry, 9 plus 9 18 1 19, 1 carry, and this is 5. Now I have to divide. So first let us divide with 5. So 5 1 the 5, 4 49, 5 9 the 45, 45 plus 4 40, 5 8 the 40, and here 5 1 the 5, 5 1 the 5, 4 48, 5 9 the 45, 3 35, 5 7 the 35. 198 divided by 1197. Now is this divisible by any other number? So 9 plus 1 10, 10 plus 8 18. Here 1 plus 1 2, 7 plus 2 9, 9 9 the 18. So with 9 I can cancel them. So 9 with 9 I will cancel. So 9 to the 18, 9 to the 18. Here also with 9 I will cancel. 9 1 the 9, 2 29, 29. So 9 3 the 9 3 the 27, then 2 9 3 the 27. So 22 upon 133. Okay, so I will get answer as 22 upon 133. So 22 upon 133 is the answer. Okay, little difficult question. Yes. Okay, fine. Next question. There are 3 coins. One is two-headed coin. Another is biased coin that comes up head 75% of the time, and third is unbiased coin. One of the 3 coin is chosen at random and tossed. It shows the head. What is the probability that it was a two-headed coin? Okay, so now here the sample space is divided in 3 partitions. Okay, first partition is that the coin is two-headed coin. Second partition that it is biased, and third is that it is unbiased. So I have 3 events. E1 is the coin is two-headed coin. E2 is the coin is biased coin. And E3 is coin is unbiased. Okay, biased means probability of getting head or tail is something different from 50%. Okay, so probability of E1. Now there is an event A that it shows a head. Event A is what? The toss, I will say, shows head. Okay, we have to find possibility that when toss shows head, it is a two-headed coin. Means we have to find possibility of E1 when A is known. This is our question mark. Now possibility of E1 is same as possibility of E2, is same as possibility of E3, is equals to 1 by 3. Selecting any of the coin is having the same possibility 1 by 3. The possibility of E1 is equal to possibility of E2 is equal to possibility of E3 is 1 by 3. Now possibility of getting head when it is known that it is a two-headed coin, so it is 100% possibility. Possibility of getting head when it is a biased coin, so for biased coin possibility of getting head is 75%, so 75 upon 100, that is 0.75, and possibility of getting head when it is unbiased coin, we know that this is 1 by 2, half. Okay, so this 75 divided by 100, better we keep in fraction, that is 25 3s and 25 4s. Okay, so that will make our calculation easy. Now using Bayes theorem, probability of E1 by A will be equals to probability of E1 into probability of A by E1 whole divided by probability of E1 into probability of A by E1 plus probability of A2 into probability of A by E2 plus probability of E3 by probability of E3 into probability of A by E3. Is equals to, now probability of E1, what is the possibility of E1? It is 1 by 3 into possibility of A by E1, so A by E1 is 1 whole divided by possibility of E1 is 1 by 3 into 1 plus E2 is 1 by 3 into A by E2 is 3 by 4 plus 1 by 3 into it is 1 by 2. Okay, so this is equals to 1 by 3 upon, here it is 1 by 3 plus 3 will cancel, so it is 1 by 4 plus 1 by 3 to the 6. We will take LCM of this 3, 4 and 6. So LCM of 3, 4 and 6 is 12. So this is 1 divided by 3 divided by, here it is 4 divided by 12 plus it is 3 divided by 12 plus here 2 divided by 12. So this is equals to 1 divided by 3 whole divided by 4 plus 2 6, 6 plus 3 9, 9 divided by 12. So 3 1s are 3, 3 4s are 12. So this is 1 divided by 3 into 4 divided by 3. So ultimately we will get 4 divided by 9. So 4 divided by 9 is the required possibility. 4 divided by 9 is the possibility of getting head when it is a two-headed coin. So possibility of getting head using two-headed coin, we can say, is 4 upon 9. This is our required possibility. Okay, an insurance company insured 2000 scooters driver, 4000 car driver and 6000 truck driver. The probability of an accident are 0.001, 0.003, 0.15 respectively. The probability of accidents are, means the possibility that insured scooter driver will met with an accident is 0.001. A car driver will met an accident is 0.003 and a truck driver will met an accident is 0.15. One of the insured person met with an accident. What is the probability that he is a scooter driver? So insured person met an accident, so it is known that accident was there. Now we have to find that it was a scooter driver. So again, sample space is divided in how many partitions here? It is divided in 3 partitions. One is your scooter driver, one is car driver, one is truck driver. So here I will say that E1 is the event that the driver is insured scooter driver. So it is insured scooter driver. E2 is insured car driver. And E3 is insured truck driver. So E1 is insured scooter driver, E2 is insured car driver, and E3 is insured truck driver. And I have an event A. Event A is insured person meets with an accident. Okay, so here possibility of E1 is I have 2000 scooter driver, so this is 2000 divided by total number of driver 2000 plus 4000 plus 6000, 4 plus 2 6, 6 plus 6 12,000, so this is 12,000. Now 2000 divided by 12,000 is 1 upon 6. Possibility of E2. E2 is 4000 divided by 12,000. So this is 1 upon 3. And possibility of E3 is 6,000 divided by 12,000. So this is 1 by 2. Possibility of A by E1. So possibility of A by E1 is given 0.01. 0.01. That we can say that 1 upon 100. Possibility of A by E2. A by E2 is given as 0.03. 0.03, that is 3 divided by 100. And possibility of A by E3 is given by 0.15, means 15 upon 100. Yes, 15 upon 100. We have to find possibility of what is unknown. What is the probability that he is a scooter driver? So probability of E1 by A. Possibility of E1 by A, this is a question mark. So I will say that using Bayes theorem, possibility of E1 by A is equals to possibility of E1 into possibility of A upon E1 whole divided by possibility of E1 into possibility of A by E1 plus possibility of E2 into possibility of A by E2 plus possibility of E3 into possibility of A by E3. So possibility of E1, possibility of E1 is 1 by 6, so it is 1 divided by 6 multiplied by possibility of A by E1 is 1 upon 100, whole divided by, here we have 1 by 6 into 1 divided by 100 plus possibility of E2. Possibility of E2 is 1 by 3 into A by E2 is 3 divided by 100 plus possibility of E3 is 1 by 2 into possibility of A by E3 is 15 divided by 100. This is equal to, numerator will become 1 divided by 600 and denominator is 1 divided by 600 plus, this is 1 divided by 100, but I will write this as in terms of 600, so I will multiply and divide by 2, so this is 6 upon 600 and plus here this is 200, so I multiply by 3, 45 divided by 600. I have done this to make calculation simple, so this is 1 upon 600 and denominator 6 plus 1 7, 7 plus 45, so 7 plus 5 12, 1 carry, 4 plus 1 5, 52 divided by 600. Now this 600 and 600 will cancel and finally I will get 1 divided by 52. So 1 divided by 52 is the required probability. So we can say that therefore required probability is, therefore required probability is equals to 1 divided by 52. Okay, a few more questions are there that we will discuss in our next class. So thank you for being with me in this class.